Okay, let's cover the review for exam 3. This is covering 4-1, 4-2, 4-3, 5-1, 5-2, 5-3, and 5-5. And I've provided you with a bunch of formulas here. If these are things you don't know, then be great to have on your note card because I am not going to be providing any formulas on the exam. Remember, you can use only one side of 1 3x5 note card. Please don't try to do any further than that. It makes me question things, and I don't want to question things. All right, so we're going to start with the quadratic down here. And remember, a quadratic's a parabola, and we're given f of x is 2x squared minus 8x plus 5. We want to rewrite it in vertex form, but the first thing we want to do is give the vertex. We need to find the vertex before we can do that. To find the vertex, remember the vertex is hk, and to find h, we can use negative b over 2a. It's listed up here as well. So we'll start with that. So h is negative b, so negative b is negative 8, so negative 8 over 2 times a is the coefficient of x squared, which is 2. Negative times a negative is a positive 8. 2 times 2 is 4. 8 divided by 4 is 2. So now we can find k. K is just f of h, so that means f of 2. We substitute 2 everywhere there's a k, everywhere there's an x. So 2 times 2 squared minus 8 times 2 plus 5. All right, I'm not going to skip steps here. 2 squared is 4. Stop it. Making me crazy. Negative 8 times 2 is negative 16 plus 5. 2 times 2 is 8. 2 times 4 is 8 minus 16 plus 5. And I do not have a calculator. Of course I don't. So I'm going to use my notes over here. That is negative 3. So my vertex is 2, negative 3. All right. I can start with my vertex form, but let's do that. Let's start with the vertex form. And I can do my axis of symmetry right now because remember the axis of symmetry is x equals h. So x equals 2. Do not just write 2. That's not the axis of symmetry. Axis of symmetry is a line. 2 is not a line. It must be x equals 2. Be careful. All right. Domain of range, y-intercept zeros. All right. So let's go to the vertex form. F of x, a, x minus h squared plus k. And that's provided to you up top as well. So f of x, we have to find a, x minus our h is 2 squared, and our k is negative 3. Now to find our a, we need to do what? We can look up here. It's right there. It's 2. No solving for that. All right, now we have our vertex form. That is number 1, that is done. 2 is done. 3, I can answer now. Because my A is positive, that tells me I'm going to have a minimum. It is going to be, well, at 2, negative 3, 1, 2, 1, 2, 3, I've got a vertex, and then it is going up. So I have a min. All right, find the axis of symmetry, did that. Domain and range. Domain for any quadratic is always the same, negative infinity to infinity. And the range strictly has to do with the k value and whether it's a min or a max. Because it's a min, remember, range is from the lowest to the highest. So coming up from the bottom, we start at negative 3, it's included, and it goes towards positive infinity because it keeps going on and on. All right, find the y-intercept. Well, that's where we let x equals 0. I'll just come over here, f of 0. 2, 0 minus 2 squared minus 3. Or I could do this one up here. You know what? It would honestly, it would be better if you used this. Because what if you did this wrong? What if you did this wrong? So let's not do that. Let's just cover CYA, cover your cookies, just in case you did this wrong. Let's not lose more points. So f of 0 is 2, 0 squared minus 8 times 0 plus 5. 0 squared is 0, so 2 times 0 minus 0 plus 5, 0, 0, 5. So 0, 5 is my y-intercept. All right, the x-intercept, find the zeros, that's your x-intercepts. And that's, again, let's use the actual quadratic up here, not the one we created. That's where we let our f of x equal 0. So you let f of x equal 0 and solve for x. So 0 equals 2x squared minus 8x plus 5. Seems a little bit, could just be my eyes. Oh, that's just me. All right. Okay, can we factor this? Well, I can try. 2x, x. I'm going to try 5 and 1, 5, 2. Nope, that doesn't give me 8. How about 1 and 5, 10 and 1? Nope, that doesn't give me 8. So not factorable like this. I'm going to go straight to the quadratic. And that's also given to you up here. Make sure if you don't have it memorized, that you have that on your note card. Is negative b, and b is negative 8. So negative 8 plus or minus the square root of b squared, negative 8 squared minus 4 ac. All of that is over 2 times a. All right. So 8 plus or minus the square root 64 minus 4. Is that right? 64 minus 40? Yeah, 64. Negative 8 squared is 64. Negative 4 times 2 is 8 times 5 is negative 40. So 24. All of this is over 4. Now, this breaks down into the square root of, it does have a perfect square in there, which is 4. And it leaves you the square root of 6. So when you rewrite this, because you do want to reduce, square root of 4 is 2, square root of 6 over 4. I find students make fewer mistakes if you don't write it like this and you instead write it as 8 over 4 plus or minus 2 the square root of 6 over 4. I find they make fewer mistakes. Just like what we do with the complex numbers, I would highly recommend you writing it like this. 8 divided by 4 is 2 plus or minus, and then 2 and 4 reduces to give you square root of 6 over 2. Those are your 2 zeros. We know we need 2 because our degree is 2. Go to the next one. All right, given vertex and a point. We need to write function in vertex form. Okay, well, that's going to start off as f of x, a x minus h squared minus, what's going to be minus 2? So plus k. All right, we need to find a. We can use the point that they're giving us to find a. Remember, this is your x and this is your y, or your, in this case, f of x. So 6 equals a, 5 minus 3 squared minus 2. 6 equals a, 5 minus 3 is 2. I'm going to go ahead and add 2 to both sides. And 2 squared is 4. Divide both sides by 4. A is 2. Okay. So f of x is 2 x minus 3 squared minus plus k, which is minus 2. All right, what was my previous one? Just want to make sure it's not the same thing. It's not. Okay. Just because you never know with me. All right, so there's vertex form. Standard form just means we expand this. Standard form, or actually it's general form, not standard. Standard is vertex. The general form is going to be taking the f of x 2, and we're going to expand x minus 3, the squared minus 2. You have to do either distribute your 2 over the 1 binomial, or I just like to go ahead and just multiply my 2 binomials. And then I'll distribute. X squared minus 3x is minus 6x. Negative 3 times negative 3 is 9. use whatever method you want to use. And now I'm going to distribute my 2. And lastly, I'm going to combine my like terms. There is my general form. There is my vertex form. What else? Min or max? Well, we have a min at, because of the A is positive. So it's going to be at 3, 1, 2, 3, -2, and it is going up. So we have a min. Axis of symmetry is x equals, and at x equals 3. Here's my axis of symmetry. Domain is always the same. For quadratics, range has to do with your k. In this case, it's -2, and it is a min. So -2 to positive infinity. Y-intercepts. Okay, this we're going to have to either use one of these 2 forms. I'm going to go with my first one because what if I made mistakes here? Again, CYA. So I need to put f of 0, the y-intercept is where f of 0, 2, 0 minus 3 squared minus 2, 2, -3 squared minus 2. -3 squared is 9. Be careful putting this in your calculator. If you just put -3 squared, it's going to give you -9, and that will be wrong. 2 times 9 is 18, minus 2 is 16. So my y-intercept is 0, 16. All right, then we need to find our zeros, which are our x-intercepts. And I'm going to take this one again, just because it'll be easier to solve with the square root property, and let your f of x equal 0. This is the x-intercept, or the zeros. 2x minus 3 squared minus 2. All right, to solve with square root property, I need to move this positive, make this positive on both sides. 2 equals 2x minus 3 squared. Divide both sides by this 2. This becomes 1 equals, this one's gone, x minus 3 squared. And then the square root property, we take the square root of the side with the square, and then plus or minus the constant side. So plus or minus square root of 1 is 1, equals x minus 3. And then lastly, to solve for x, we just add 1 to both sides. Before I do that, however, I'm going to break these apart. I'm going to make it positive 1 equals x minus 3, and -1 equals x minus 3. Okay, and then add 3 to both sides. So x equals 4, and add 3 to both sides. X equals 2. So my zeros are 4, 0, and 2, 0. There we go. I think that's it. Yep. All right, next victim. Given a graph to determine the vertex. Well, the vertex is this little guy right here. And then it's 2. Oh, this one again, 2, -3. We just had that one. Frustrating. I didn't realize that. All right, so my vertex is 2, -3. My y-intercept, which we just found, should be, did we just do that? Oh, no, it's 3, -2. Okay. I don't know why I'm thinking that way. That's okay. There is a min right here. Axis of symmetry is the line that goes through the vertex. And that line is x equals 2. Domain is always the same for quadratics, -infinity to infinity. The range is starting at -3. Oh, this is the first one I did. All right. Equation of the function. Well, let's pretend like it's not this first one. Okay. So f of x is a x minus h. So x minus 2 squared plus k, which is -3. Now, let's just know that I'm not going to repeat questions on the exam. I'm going to do hopefully a much better job. We need to find a. All right, let's just assume we don't know what a is. So in order to do that, I love to use the y-intercept because it just makes life easier. If you know what the y-intercept is, use it. Otherwise, you can use any other point on the line other than the vertex. You cannot use the vertex. All right, so y-intercept is 1, x's are 0, and then we solve for a. Add 3 to both sides. -2 squared. -2 squared is 4. Divide both sides by 4. Well, that makes it easy. A is 1. So my equation is just x minus 2 squared minus 3. And lastly is find the zeros. Now notice you cannot see what the zeros are here. You're not going to be able to guess what that is. I do not want decimals. I want exact. So to do that, I'm going to take my equation that I have, and I'm going to let f of x equal 0. Add 3 to both sides. Square root property, take the square root of both sides, plus or minus on your constant side. And then lastly, add 2 to both sides. 2 plus or minus the square root of 3. Those are your zeros. Application. Oh, the ball. Okay. All right. The ball is thrown from a building. H of t equals quadratic. How long does it take for the ball to reach max height? That is your h for your vertex. What is the max height is your k from your vertex. And then when does the ball hit the ground is when f of x, or in this case, k of t. Oh my God, that's an h. H of t equals 0. Good there. Okay. There's no time here, so I'm gonna assume seconds because I do need to know units. Assume seconds for time and feet for, we'll just go with feet this time instead of meters. All right. So the first thing you need to do for number 1 is to find h. H is negative b over 2a. Since we have a general form, we can just do it that way. Negative b 24 over 2 times a. And I don't have my calculator. So that's negative 24 over negative 9.8, which is 2.45. So I'll come back and let's just go and write our answers. In 2.45 seconds, ball reaches max height. All I need. Give me a sentence. The next one is, what is the maximum height? The big thing here is not just the answer, but this. I need to know that that's your seconds, or I at least need to know that what you're giving me here is answering question number 1. I need to know seconds though. 2 is to find my k. That's f of h. So in this case, it's going to be h of 2.45. So negative 4.9. A lot of people forget this negative. Be careful. It has to be a negative. 2.45 squared plus 24 times 2.45 plus 8. All right, what are my numbers here? So negative 4.9, 6.0025 plus 58.5 plus 8. And then you multiply and then add them all together, and you get 37.39. So max height is 37.39 feet. The last thing is you let h of t equal 0. And you're not going to factor this. You're just going to use your quadratic. Negative b plus or minus the square root of b squared minus 4 a c all all of that over 2 times A. All right. This becomes, well, this is a t, not an x. Negative 24 plus or minus. And I got, after I've squared this and then multiplied these together and added it, basically, I got 27.07 over negative 9.8. Now, you need to break these into 2. We need to take this up here and go t equals negative 24 plus 27.07 divided by negative 9.8, and t equals negative 24 minus 27.07 divided by negative 9.8. We're going to get 2 different answers here. One is negative 0.313, and the other one is 5.21. Well, time can't be negative. We do not have a DeLorean. So this had to be our answer. So the ball hits the ground in 5.21 seconds. All right, my answer for that one. Next one, given the least possible degree, find the least possible degree. Well, it's going to be an odd exponent because they're going in different directions. If they were going in the same direction, they'd be even. So it has to be odd for sure. And then, well, I can use my max turns. 1, 2, 3. I have 4 turns, and max turns is n minus 1. I don't think I provided that for you. I did not. You're going to probably want that on your note card if you don't have that, if you don't know that by memory. So your max turns are n minus 1. I have 4 max turns. Add 1 to both sides. So my degree is at least 5. So find the least possible. Right now it's at least 5. We're going to go with that. Find the zeros. All right. Zeros and their multiplicities. So I've got 1 to 4. Oh, this is negative 4. Negative 3. Negative 1. 3 and 4. And it looks like they are all just fruit slicing. I think it's called Fruit Ninja. Each of those going through those points. So multiplicities of 1 for each, which gives us 5 again. So least possible degree, I would say 5 for that. Okay, make sure and answer it. Don't just leave it blank. I did that. Leading term. Well, it's going to have to be what? It's going to have to be a negative for sure. Find the leading coefficient. Describe the end behavior. Well, we need to find the, we're going to have to find the actual problem. So let's look for that. F of x is a, because I don't know what that is. But I can take each of these zeros and set this x equal to negative 4 and set them equal to 0. So if you take x minus x equals negative 4 and add 4 to both sides, you get x plus 4 equals 0. That's what goes in your parentheses. We're going to have 5 of them. X plus 3, x plus 1, x minus 3, and x minus 4. If you do that for each one of these, that's what you're going to get. So this tells me 1, 2, 3, 4, 5. I got my degree. Oh, I have a y-intercept here of 0, negative 1. I can use that to find my A, and that will help me find my leading coefficient and my leading term. So negative 1, 0 plus 4, 0 plus 3, 0 plus 1, 0 minus 3, 0 minus 4. 4 times 3 is 12. Well, I'm not going to do this. 4, 3, 1, negative 3, negative 4. 12 and 12 is 144. Positive, and then divide both sides by 144. So there's my A. Knew it was negative. So my actual And you're going to have to write the polynomial as well. Negative 1 over 144, and only in this form. You do not have to condense it to general. X plus 4, X plus 3, X plus 1, X minus 3, and X minus 4. There is the factored form. All right. So the answer to the leading term is negative 1 over 144 x to the 5th. And then the leading coefficient is negative 1 over 144. And behavior. I'll come back here and do this. As x approaches negative infinity, f of x is approaching positive infinity. Over here, as x approaches positive infinity, f of x is approaching negative infinity. All right, that's it for that one. Find all zeros. Okay. So first thing I'm going to do is look at these two and then these two, because there's 4 terms. All right, the first one, what do they have in common? And this is 0 equal, because we're finding zeros. They have an x squared in common. I can factor that out. When I do that, I'm left with x minus 4. I want, whatever I do over here, I want to end up with an x minus 4. So I need to factor something out that gives me an x minus 4 from this. As long as they're in order from the highest degree to the constant, this works every time if it's factorable. So I'm factoring out a negative 4. And that leaves me with x minus 4. Now, between these two terms, what do they have in common? They have x minus 4 in common. So we're going to factor that out. And we're left with x squared minus 4. Now there's 2 different options here. You can either go ahead and set these each equal to 0, or you can continue factoring. This is the difference of 2 squares. It does factor to x minus 2, x plus 2. If you want to do that, or you can use a square root property. It's your choice. I'm going to go ahead and do this. Set each of those equal to 0. And solve for x. So my zeros are 4, 0, 2, 0, and negative 2, 0. We have 3 of them. Degree of 3 makes complete sense. All right, find all zeros. They're out of order. Please make sure that you put them in order. So 2x cubed plus x squared minus 8x plus 4. I think this one was an issue, and I did. I had to change it. I changed it on my notes as well. Okay. Yeah, because otherwise it would not have worked with that negative. All right, so looking at our first 2 terms and then our second 2 terms. The first 2 terms have an x squared in common. Leaves me with 2x plus 1. Then I can factor out a 4, and that leaves me with 2x plus 1. Between these 2 terms here, they both have 2x plus 1 in common. X squared plus 4 is left. You cannot do what we did up here and factor it into the 2 binomials. This is a difference of 2 squares. You cannot factor the sum of 2 squares the same way. We can solve for it, but we can't factor it in the same method. Set each of these terms equal to each of these binomials equal to 0 and solve for x. The first one, we're just going to subtract 1 from both sides. 2 is attached to x by multiplication. We're going to divide both sides by 2. So our first 0 is negative 1/2. All right, the next one, we're going to subtract 4 from both sides. You don't want your x squared to be negative, so don't move your x squared over. That's just going to make life more difficult. It adds an extra step, not necessary. Just move the 4 over by subtracting it from both sides. Negative 4 is equal to x squared. To get rid of a square, we have to take the square root. Remember the other side, because it's an equal sign, we take plus or minus square root. So x is equal to plus or minus the square root of 4 is 2, the square root of -1, because remember the square root of -4 is the same thing as the square root of 4 times the square root of -1. Square root of -1 is I. Let's go back to the complex numbers. So 2i, 0 is another 0, and -2i, 0 is my last. 3 of them because the degree is 3. This is a long one. You know what? I'm gonna make a second video. This is long. How do I stop this? There.